Chapter 2, Section 1, we're going to talk about integers and rational numbers. The first thing to remember is the key terms here. A whole number is any numbers starting at 0, going to a positive, 1, 2, 3, continuing on to infinity. An integer is any number that is positive or negative. So we start with 0, we go -1, -2, until you go to infinity on this side, 1, 2, 3 positive, and you go to infinity on this side. A rational number is a number that can be written as a quotient of integers. So basically what they're saying is if I have A and B, and those are integers, that equals a rational number, okay? For example, if I say 4 over 2, that is a rational number because it comes out to be 2. If I say something like a half, so if I divide 2 into 10 or 1 half is equal to 0.5, that makes that a rational number. If I do 1/3, that comes out to be 0.333 with a number over or a line over it, meaning go on for infinity. This would not be a rational number. So let's understand the number line. First of all, they give you different integers here, and that's what we're talking about, a number line. When we're talking about a number line in the integers, what we're looking at, for example, here it's asking for -3. So on the number line, it falls here. That would be less than 0. Okay? -1 would fall here, 2 would fall here, and 4 would fall here. The key thing to remember about this is this. Any time that you go up this way, it's getting larger. Okay? Anytime that I go down this way, the number is getting smaller or less of a value. Okay? That being said, let's talk about classifications of numbers. I've got a couple numbers here. 3, 1.7, -14, a half, and 1/3. Let's look at this. By definition, is 3 a whole number? Yes, it is. Okay? Is it an integer? Yes, because it's a positive number. Okay? Is it a rational number? Yes, it is. 1.7, is it a whole number? No, because it's technically not a counting number. Is it an integer? No, because it's not a whole number, positive or negative. Is it a rational number? Yes, it does have a decimal, it does stop. -14, is it a whole number? No, the reason not is because it's a negative number, so therefore it would be a yes on an integer, and then also yes, it would be a rational number because you could divide it out equally. A half? No, on a whole number because it's not a counting number. Is it an integer? No, because it would come out into a decimal. Is it a rational number? Yes, it is. And last, 1/3. Is it a whole number? Once again, no. It's not a counting number. Is it integer? No. And is it a rational number? No. Because if I divide 3 into 1, I'm going to come out with 0.3333 continuing. Last part of Chapter 2, Section 1, we're going to talk about is absolute numbers or absolute values of a number. And the thing to remember about this, that it's the distance away from 0. So anytime that you have a negative as an absolute number, it's going to be a positive. Okay, so let's look at this one right here. We have the absolute value of -3. How many moves is it away from 0? Well, that would be 3. Okay, here we have 2. the absolute value of 2. Well, how many moves is it away from 0? 2. Notice how both of these become positive. Now to throw a little bit of a wrench in here, what I'm going to do is I have the absolute value of -5, we know is 5. But based on the rule that I gave you in the rules of the game, anytime you have a negative times anything next to parentheses or absolute value, you've got to multiply it through. So now I say negative times that, so therefore it'd be a negative. Same instance for this one. The absolute value is 4, and then negative times that positive would be a negative. Last couple things here. Let's do a couple addition. I have the absolute value of -3, which would be a positive 3, plus 2, which would equal to 5. Here I have the absolute value of -5, which is 5, plus the absolute value of -3, which is 3. So 5 plus 3 would be 8. Last thing in this chapter is just basically a conditional statement, or the if-then statement. And when I talk about if-then, the main thing is it can be true or false. For example, you have this sentence down here that says, if a number is positive, then it is a whole number. This here is called the hypotenuse of the conditional statement, and this is the conclusion. And once again, they can be true or false. Again, if there's any questions, feel free to ask me in class. Other than that, have a good evening.